we facing the same doom? Researchers reconstruct the dark and frozen conditions on Earth after Asteroid Megastrike. We have a lot of scars on Earth of impacts. So are we any more empowered to stop annihilation by an asteroid strike? The apocalyptic time that many believe wiped out the dinosaurs has been reconstructed by scientists in unprecedented detail. They found tiny droplets of sulfuric acid formed high up in the air after the well-known impact of a large asteroid 66 million years ago, blocking the sunlight for several years. They say this big chill, quote unquote, had far more catastrophic effects at first thought, causing global temperatures to plummet for 3 years, even mixing oceans and killing off sea life. The big chill, following the impact of the asteroid that formed the Chicxulub crater of the Yucatan Peninsula in Mexico, is a turning point in Earth's history. This is what Julia Brugger says. She's from Potsdam Institute for Climate Impact Research, PIK, lead author of the study, published in Geophysical Research Letters. She said, "We can now contribute new insights for understanding the much debated ultimate cause for the demise of the dinosaurs at the end of the Cretaceous era. Previous theories focused on the shorter-lived dust ejected by the impact. The new computer simulations, though, show that the droplets resulted in long-lasting cooling, a likely contributor to the death of land-living dinosaurs." The team concluded these dramatic environmental changes suggest a pivotal role of the impact in the end Cretaceous extinction. Plants died and death spread through the food web. In addition, additional killing mechanism might have been a vigorous mixing of the oceans caused by the surface cooling, severely disturbing the marine ecosystems. To investigate the phenomenon, the scientists used computer simulations normally applied in different contexts, a climate model coupling atmosphere, ocean, and sea ice. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. It adds to previous research showing that sulfur-bearing gases that evaporated from the violent asteroid impact on our planet's surface were the main factor for blocking the sunlight and cooling down the Earth. In the tropics, annual mean temperature fell from 27 to 5 degrees Celsius, so it was almost freezing. It became cold, really cold, says Brugger, and global annual mean surface air temperature dropped by at least 26 degrees Celsius. The dinosaurs were used to living in a lush climate. After the asteroid's impact, the annual average temperature was below freezing point for about 3 years. Eventually, the ice caps expanded. Even in the tropics, annual mean temperature went from 27 degrees to a mere 5 degrees. The long-term cooling caused by the sulfate aerosols was much more important for the mass extinction than the dust that stayed in the atmosphere for only a relatively short time. It was also more important that local events like the extreme heat close to the impact, wildfires, or tsunamis, says co-author George Fulner, who led the research team at PIK. It took the climate about 30 years to recover, the scientists found. The study of Earth's past also shows that efforts to study the future threats by asteroids have more than just academic interest. Fulner says, "It's fascinating to see how evolution is partly driven by an accident like an asteroid impact. Mass extinctions show that life on Earth is vulnerable. It also illustrates how important the climate is for all life forms on our planet. Ironically, today the most immediate threat is not from natural cooling, but from human-made global warming." The researchers studying the resulting Chicxulub Yucatan Peninsula dinosaur crater impact recently recreated a stunning animation to show that the object that hit the planet may have slammed nearly all the way through the Earth's crust. The animation shows that the impact caused the Earth's surface to slosh back and forth like a liquid. The finding could help explain how impacts can change the faces of planets, and how collisions can create new habitats for life. And speaking to Live Science, Sean Gulick, marine geophysicist at University of Texas at Austin, co-author of the study, explained that while asteroids do occasionally hit the Earth, changes to the surface are largely the result of rain and wind, as well as plate tectonics, which generate mountains and ocean trenches. Other rocky planets in our solar system, such as Mars, differ as weather and plate tectonics have little effect on their surface. Mr. Gulick said, the key driver of surface changes on those planets is constantly getting hit by stuff from space. The researchers from Imperial College London and the University of Texas at Austin hope to learn more about the impact effects found on other objects in the solar system. Large craters often have rings of hills, known as peak ridges, in their center, but studying these is difficult as they mostly exist on extraterrestrial rocky bodies and are hard to access. To overcome this issue, the researchers looked at the Yucatan Peninsula dinosaur crater, the Chicxulub crater in Mexico, which was a result of the huge asteroid crash 66 million years ago. The crater represents the only intact peak ring on Earth, which has not been eroded. The researchers drilled almost a mile below, 0.8 miles below the seafloor, to examine rock samples at the impact site. In the samples, it discovered granite that was likely to have been buried deep for about 500 million years. Mr. Gulick said, these deeply buried rocks rose up to the surface of the Earth within the first few minutes of the impact. They showed evidence they experienced a high degree of shock from the impact. After the asteroid had hit, the researchers believed that the Earth would have behaved like a slow-moving fluid, quote-unquote. Mr. Gulick said, the stony asteroid would have opened up a hole probably almost the thickness of the Earth's crust, almost 18 miles deep, and on the order of 50 to 62 miles wide. The Earth would have then begun to flow to fill in the hole, collapsing the size of the crater inward, he said. And Mr. Gulick said, at the same time, the centers of this hole starts reaching upwards, like when you throw a rock in a pond, you get the water droplet rising in the middle. The center would have risen up from the surface of the Earth as much as 9 miles, and then became gravitationally unstable, collapsing downwards and outwards. The BBC has described the rock lifting as creating instant Himalayas, quote-unquote, which is around 8,848 meters high. This process would have resulted in the peak ring of mountains. As well as understanding this process, the researchers also discovered that the rocks from the peak rings were more porous and less dense. This would have provided niches for simple organisms to take hold. At the same time, nutrients would have been provided from water heated inside the Earth's crust. Professor Joanna Morgan, lead author of the study from Imperial College's Department of Earth Science and Engineering, said, the early surface of the Earth was mainly solid granite, lacking spaces for life to evolve. She said the impact created rocks that were highly fractured with a ridiculously high porosity, and this was basically quite a good thing for early life. The little gaps in the rocks provided a habitat for tiny organisms to grow. She added, it's hard to believe that the same forces that destroyed the dinosaurs may have also played a part much earlier on in Earth's history in providing the first refuges for early life on the planet. She said, we are hoping that future analysis of the core samples will provide more insights into how life can exist in these subterranean environments. This was by Mark Prigg on Daily Mail UK on Bended Reality. Please leave your comments and thank you for your support.